All right, so let's find the area below this curve and above the x-axis. All right, so unlike the last questions, we weren't given like an upper bound and a lower bound for x, but you can see that we're going to be bound by the x-intercepts, right? That's what we're interested in. So step number one, let's actually just find where the x-intercepts for this function would be. Okay, so it'd be 0 is equal to x squared minus 4x plus 5. So, sorry, negative x squared. So I'm going to bring everything over to the other side just so I can get rid of that negative out front. So now I've got x squared plus 4x minus 5 is equal to 0. And then if we factor this, we get x minus 1 and x plus 5. And then from here, we'd say, okay, x is equal to 1. Well, that makes sense, doesn't it? And then here, x is equal to negative 5. And that makes sense, doesn't it? Okay, so those are our bounds. We could see it from the picture on this one, but we won't always have that luxury, right, of seeing exactly where the x-intercepts are. Okay, so then from there, I'm just going to make the statement that f of x is equal to negative x squared minus 4x plus 5. All right, so then if that's the case, then we know it must be true that the derivative of the area function is equal to the same thing, is equal to negative x squared minus 4x plus 5. So again, this is a differential equation, and the way we solve this is by saying what the area function would be that would make this true. So then the area function would have to be the antiderivative. So capital F of x. Okay. So now we'll actually just say what that is, right? The area function would be, now taking the antiderivative of all of this, so it would be negative x to the power of 3 over 3, and then minus, and then this would become, so this would be to the power of 2 over 2. So this would be just now minus 2x squared plus 5x and then plus c. Okay, so that's in general, this is what our equation is, but now we need to actually bound it to our x-intercepts. So we'll say the area function at 1, okay, just the upper bound typically, is equal to, and then it would be the antiderivative at 1 minus the antiderivative at negative 5. Okay, so the area at 1 would be, so this would be in brackets negative 1 cubed over 3 minus 2 times 1 squared plus 5 times 1 plus c. And I'm probably going to run in the room here. Hopefully you guys did a little better than I did. So then that minus, and then it'd be minus negative 5 cubed over 3 minus 2 times negative 5 squared, and then plus 5 times negative 5 plus c. So again, our c's will cancel because I've got a negative out front here. And if we simplify down each of those, we get the area at 1 would come out as, so all of this comes out as 8 over 3 minus, and then all of this comes out as 100 over 3. Sorry, negative 100 over 3. So then minus a negative, so then we're going to be adding. So we get the area function at 1 is 108 over 3, which is equal to 36.